All right, this is the story about two weak acids. I have here listed two acids. Acid number 1 on my left, acid number 2 on my right. Hydrocyanic acid versus hydrofluoric acid. Hydrocyanic acid has the formula. Hydrofluoric acid has the formula HF. Neither of these are on my list of strong acids, therefore both of them are weak acids. The hydrocyanic that is equal to 4, and the hydrofluoric has a Ka that is 6.8 times 10 to the negative 4. Compare the two Ks and tell me which one is the stronger weak acid. Based on the size of the Ks, the hydrofluoric acid is the stronger weak acid. And the hydrocyanic next. Hydrocyanic acid. Write the formula for the conjugate base of hydrocyanic acid. The formula for the conjugate base is and the formula for the conjugate base for the hydrofluoric is F minus. Now predict which conjugate base is stronger. Because the hydrofluoric acid is the stronger weak acid, it's going to have the weaker conjugate base. Because the hydrocyanic acid is the weaker weak acid, it's going to have All right, so while we're still working with the conjugates, let's calculate mathematically the Kb of the cyanide ion and the Kb of the fluoride ion. Calculate the Kb the same way, Kw, Ka of the HCN, the Kw over the Ka of the HF. At 25 degrees Celsius, Kw is 1.0 times 10 to the negative 14. 1.0 times 10 to the negative 14 divided by 4.9 times 10 to the negative 9 is going to give 2.0 times 10 to the negative 6 for the hydrocyanic acid. 1.0 times 10 to the negative 14 divided by the Ka of the hydrofluoric is going to give me 1.5 times 10 to the negative 11. Again, notice, just like we predicted, this guy, the larger number, so he is the stronger conjugate base. So predicted it and mathematically proved it. Next thing I want to know, what is the hydrogen ion concentration of each? The hydrogen ion concentration of the hydrocyanic acid, work right, Ka is equal to x squared over 0.30 minus x, using your solver key. Your hydrogen ion concentration 3.8 times 10 to the negative 5 molar. For the hydrofluoric acid, it's going to be 0.014 molar. Now calculate the pHs. pH of the hydrocyanic acid, which is the negative log of 3.8 times 10 to the negative 5, is going to be 4.42. Since my concentration has two sig figs, my pH ends 2 digits to the right. The pH of the hydrofluoric acid is going to be 1.85. Notice a couple of things. The hydrofluoric acid, which is the stronger weak acid, will have a lower pH. It's got a higher concentration of hydrogen ions, but a lower pH. Remember, they're opposite. The more hydrogen ions you got, the lower the pH. The less hydrogen ions you got, the higher the pH. They're opposite. Now, before we go any further with this comparison, which one would you predict to have the larger percent dissociation? If you suggested the hydrofluoric acid, you are correct. Let's do it mathematically. Percent dissociation is the hydrogen ion concentration divided by initial times 100. And for the hydrofluoric acid, it's going to come out to be 4.7%. And for the hydrocyanic, it comes out to be 0.013%. So again, proving our point, the 4.7% is a larger percent dissociation because hydrofluoric acid is more product favored than the hydrocyanic acid. So we're going to do a little synopsis here. Ka of the hydrocyanic acid was 4.9 times 10 to the negative 9. The Ka of the hydrofluoric was 6.8 times 10 to the negative 4. The pH of the hydrocyanic was 4.42. Of the hydrofluoric was 1.85. Conjugate base identity, cyanide ion, conjugate base identity, fluoride ion. The Kb for the hydrocyanic acid was 2.0 times 10 to the negative 6. And the Kb for the hydrofluoric acid was 1.5 times 10 to the negative 11. I'm going to add another column here and say percent dissociation. For the hydrocyanic, it was only 0.013. For the hydrofluoric, it was a whole 4.7%. Notice that HF is the stronger of the two. Has a lower pH. Let's do it this way. Has more hydrogen ions than the cyanic, a lower pH, but has the weaker conjugate base.